Hello friends, in this video we will discuss some properties of operations on the set. There are certain operations which we have discussed. So what are the properties of those operations on sets? So first property is closure property. Closure property means a certain set is close to certain set. So let's discuss how. So in the concepts of the set, the union, intersection and difference are closed in universal set. Means whenever we apply these operations and universal set is predefined, then these operations will always close to the universal set. Means the outcome of these operations will always be available in the universal set. Let us discuss. For example, A is set of A and B, and B is the set of A, B and D, and universal set is A, B, C and D. So these are the three sets. So universal set is predefined here. So if I find A union B, so what has become? A comma B union A, B and D. So outcome will become A, B and D. So which is closed in universal set, because these all three elements are available in universal set A, B and D. So let us talk about intersection. So if we find intersection A comma B, intersection A, B, D, which is set B, is equals to the A comma B, which is also closed in universal set, because universal set is also contains A and B. The closed in means they will always become the set subsets of the universal set. So it just mean that. And A difference B. A difference B means A comma B, difference A, B and D. So A contains by the both sets, B is contained by the both sets. So A does not have another set, so it will another element, so it is null set. So null set is also subset of the universal set. Remember we have discussed that the phi is the subset of the all sets. So a null set is also subset of the universal set. So it is also closed in universal set. There is another property which is called commutative property. Commutative property. The commutative property is valid for the union and intersection, but is not valid for the difference, which is A union B is equals to the B union A. Similarly, A intersection B is equals to the B intersection A. This is called commutative property. But A difference B will never be equals to the B difference A in certain cases. Let us consider these same sets. So A union B is, which we have already found, which was equals to the A union B is equals to the A, B and D. Let us found B union A. B set is A, B, D. Union A set is A comma B. So which is, so B union A is equals to the A, B, D, which is equals to the A union B. Let us talk about the different intersections. So A intersection B is equals to the, we have already found A comma B, and let us find B intersection A. B intersection A is means B element, B set A, B, D, the intersection, then set A contains A comma B. So which are the common elements in both sets, A and B? So A comma B is our set B intersection A, which is same as A intersection B. So we can write this A union B equals to the B union A, and A intersection B is equals to the B intersection A. But if we find A difference B, which we have already found, which was null set, but if we find B difference A, which is A, B and D, difference A and B. So A, B contained by the both subsets, but D here is additional, so it is equals to D, but it is not equals to the A difference B, which was equals to the null set. So this is the commutative property is not valid for the difference operations. So there is another property which we call identity with respect to the union. So what is the identity with respect to the union? Let us discuss. Identity with respect to unions. This is the third property. So identity means what is that set when we union with a certain set, so answer will become that set. Let us suppose set A is a certain set. So what is the set if I combine with A? So answer will become A. So that is null set. If I combine A set we have already written here, which is A comma B. If I combine with null set, so A union B will become A comma B. So phi is said to be identity with respect to the union. So there are another identities, for example, with respect to the intersection we will discuss in our next lectures. Important laws. What are the important laws? So it is very obvious, which is if for any set A union A is equals to the A, and A intersection A is also equals to the A. So it is pretty obvious, such as if I find A union A, so A is the AB union A is also AB, so our outcome will become A comma B, which is equals to the A. Similarly, if we find A intersection A, which is A comma B intersection A comma B, which is always become A comma B because it contains the similar elements, which is also equals to the A. So this property also holds. There are another properties which are called identity laws. Identity laws means identity with respect to the different operations. For suppose we are talking about the union and intersection. Here we already discussed the union identity. So what is the identity with respect to the intersection? So identity with respect to the intersection means what is the set when I intersected with the A, so our answer will become A, and that set is universal set. For suppose we have already discussed predefined the set, universal set, which is A, B, C, D, and our A set is A, B. So let us do the intersection operation, which is set A, which is A comma B, intersection into universal set, which is A comma B comma C comma D. The answer will become A comma B. So this is the identity with respect to the intersection. There are another different laws with respect to the complements. So what are those? Let us discuss those laws. For suppose if I union A with the A complement, it will become universal set. So let us find this. First find A complement, which is universal difference A, B, C and D difference A and B. So what answer will become? C comma D. So A union A complement will become A comma B union A complement, which is C comma D. So it is A, B, C, D, which is equals to the universal set. If I find A intersection A complement, it will always become phi, because we are changing these elements of the set A, so it will never contain any common element. Let us find, we have already find the A complement, which is CD. So let us find A intersection A complement, which will become A is the A comma B intersection A complement means C comma D. So they both do not contain any common element, which is the empty set or phi. We have already discussed another property, A complement whole complement is equals to the A, so which is available in our previous videos. We will not discuss in this video. So there is another property which is called universal complement, which is always become phi, because the universal complement means we have to find difference with respect to the complement. So if I find U complement means universal my difference universal set, so it will become A B C A comma D, A B C comma D. Remember, I am using those set which we have already started with. A is AB, B is ABD, and universal is ABCD. So please remind that. So if I operate this A B C D, so they all will be cancelled out, which will become phi. So this property also holds. So this was some basic laws with regarding to the operations on the sets. So we will discuss some more laws, so such as associative law, distributive law, with respect to the different operations in our next videos. Hope you find this video helpful. Please do comment and subscribe my channel. Thank you.